You're floating in the vast emptiness of space. No spaceship, no spacesuit, just you, suspended in the infinite darkness between stars. The silence is deafening. The cold is beyond anything you've ever felt. And you're about to discover what happens when a human body faces the ultimate test of survival in the most hostile environment imaginable. Hey everyone. Before we dive into this mind-bending journey through space, I want to know, where are you watching this from right now? Are you cozy in your bedroom at midnight, scrolling through YouTube? Maybe you're on your lunch break at work, or perhaps you're that brave soul watching this at 3 a.m. when you should be sleeping. Drop a comment below and let me know your location and what time it is where you are. I love seeing how this content reaches people all around the world at different moments in their day. Now, let's get back to our terrifying scenario. What I'm about to tell you will change how you think about space forever. Because what happens to your body when you float in space isn't what most movies show you. It's far more strange, far more dramatic, and in some ways far more horrifying than Hollywood could ever imagine. The moment it all begins. Imagine you're an astronaut on a routine spacewalk. Something goes wrong. Maybe your tether snaps. Maybe a piece of space debris hits you at thousands of miles per hour. Maybe there's a catastrophic failure with your spacecraft. Whatever the cause, you find yourself drifting away from safety, floating into the endless void with no way to get back. The first thing you'd feel isn't what you think. You wouldn't freeze instantly like in the movies. You wouldn't explode. Your blood wouldn't boil immediately. No, the first thing you'd experience is something far more subtle and far more terrifying. Complete and utter silence. Space is silent. Not the kind of silence you experience in a quiet room where you can still hear your heartbeat and your breathing. This is absolute silence. Sound waves need molecules to travel through, and in the vacuum of space, there are so few molecules that sound simply cannot exist. The only sounds you'd hear would be the ones coming from inside your own body. Your heartbeat, your breathing, the gurgling of your stomach. These sounds would become your only companions in the vast emptiness. But here's where it gets really interesting. You'd also experience something that no human was ever meant to experience. Complete weightlessness combined with complete isolation. On Earth, even when you're alone, you're surrounded by the invisible presence of gravity, air pressure, and the electromagnetic field of our planet. In space, all of that disappears. You become truly alone in a way that's almost impossible to comprehend. The first few seconds, your body's immediate response. Now, let's talk about what actually happens to your body in those first crucial seconds. And trust me, it's not what you've seen in the movies. First, your saliva would begin to boil. Not because space is hot, it's actually incredibly cold, but because of the lack of air pressure. On Earth, the atmospheric pressure keeps the water in your body in its liquid state. In space, with no pressure, the water in your saliva would immediately begin to vaporize. You'd feel your tongue and the inside of your mouth start to bubble and foam. It's a sensation that would be completely alien and terrifying. Your skin would begin to swell. Without atmospheric pressure pushing against your body, the gases dissolved in your blood, and other bodily fluids would start to form bubbles. This condition is called ebulism, and it would make you swell up to about twice your normal size. You'd look like a grotesque balloon version of yourself. But here's the thing that might surprise you. Your skin is actually tough enough to hold you together. You wouldn't pop like a balloon. Your skin would stretch and stretch, but it wouldn't burst. Your temperature regulation would go haywire. In space, there's no air to conduct heat away from your body, so you'd actually start to overheat from your own body heat. At the same time, any part of your body facing away from the sun would begin to lose heat through radiation. You'd simultaneously be too hot and too cold, creating a bizarre and uncomfortable sensation unlike anything you've ever experienced. The first minute, the real nightmare begins. If you somehow manage to survive the first few seconds, the first minute would bring new horrors. Your body would begin to lose consciousness, not from the cold, not from the heat, but from something far more immediate, the lack of oxygen. But here's what's really fascinating. It's not the lack of oxygen that would kill you first. It's the carbon dioxide buildup in your blood. On Earth, when you hold your breath, the uncomfortable feeling that makes you want to breathe again isn't caused by lack of oxygen. It's caused by the buildup of carbon dioxide in your bloodstream. In space, without the ability to exhale properly, this carbon dioxide would accumulate rapidly. You'd feel an overwhelming urge to breathe. Your chest would heave. Your heart would race. Panic would set in as your body desperately tried to get rid of the carbon dioxide poisoning your blood. And here's the most terrifying part. Even if you tried to hold your breath to conserve oxygen, you'd actually make things worse. The trapped air in your lungs would expand due to the lack of external pressure, potentially rupturing your lungs from the inside out. The smart thing to do, believe it or not, would be to exhale immediately. Let all the air out of your lungs. It sounds counterintuitive, but it's the only way to prevent your lungs from exploding. This would give you maybe 15 seconds of useful consciousness before the lack of oxygen would cause you to pass out. The first hour, your body becomes a frozen monument. Let's say, hypothetically, that you somehow survived the first minute. Maybe you're wearing a partial pressure suit, or maybe you're just incredibly lucky. What happens next is even more bizarre. Your body would begin to freeze, but not in the way you might expect. In movies, people freeze instantly in space, turning into ice sculptures in seconds. In reality, freezing in space is a slow process because there's no air to conduct the heat away from your body. You'd lose heat only through radiation, which is much slower than conduction or convection. The freezing would start at your extremities. Your fingers and toes would go numb first, then your hands and feet. The cold would creep up your limbs like a slowly advancing glacier. But here's what's really disturbing. You might still be conscious for some of this process. You'd feel your body shutting down piece by piece, system by system. Your blood would begin to thicken as it cooled. Your heart would struggle to pump the increasingly viscous fluid through your veins. Your brain, deprived of oxygen and proper blood flow, would start to shut down non-essential functions. You'd lose the ability to think clearly, to remember where you are or what happened to you. In a strange way, this might be a mercy. The first day, the transformation. After about 24 hours floating in space, your body would no longer be recognizable as human. You'd become something else entirely, a frozen, swollen monument to the incredible hostility of space. Your skin would be stretched tight and discolored. The lack of atmospheric pressure would have caused all the small blood vessels near your skin's surface to rupture, giving you a mottled, bruised appearance all over your body. Your eyes would have frozen solid, turning white and opaque like two marbles. But here's something that might surprise you. Your body would still be preserved. In the vacuum of space, there are no bacteria, no decomposition, no decay. You'd be perfectly preserved, like a frozen time capsule. If someone found you 100 years later, you'd look exactly the same as you did after that first day. Your body would also become incredibly brittle. In the extreme cold of space, your frozen tissues would become as fragile as glass. A small impact from even a tiny piece of space debris could shatter parts of your body like a porcelain doll. The first week, radiation's deadly embrace. Now, let's talk about something that movies never show you. Radiation. Space is flooded with deadly radiation from the sun and from deep space. On Earth, we're protected by our atmosphere and magnetic field. In space, you're completely exposed. After a week of floating in space, This radiation would begin to have serious effects on your body, even though you'd already be dead. The radiation would start to break down your DNA, your proteins, and the very structure of your cells. Your skin would begin to change color, taking on a strange, unhealthy hue that would be visible even through your frozen, swollen state. Cosmic rays, high-energy particles from deep space, would be constantly bombarding your body. These particles are so energetic that they can pass right through several feet of lead. They'd tear through your body like invisible bullets, leaving microscopic trails of destruction in their wake. If you were somehow still alive at this point, the radiation would cause radiation sickness. You'd experience nausea, vomiting, and diarrhea. Your hair would fall out. Your immune system would collapse. Your bone marrow would stop producing blood cells. It would be an agonizing way to die.
A month into your journey through space, your body would have found its rhythm with the cosmos. You'd be orbiting something, maybe a planet, maybe a star, maybe just floating in the vast emptiness between galaxies. You'd become part of the cosmic dance, a silent partner in the eternal waltz of celestial bodies. Your trajectory would depend entirely on the gravitational forces acting on you. If you were near a planet, you might find yourself in a slowly decaying orbit, spiraling inward over months or years. If you were in deep space, you might continue floating in the same direction for millions of years, or until you encountered another gravitational field. Here's something that's both beautiful and terrifying. You'd be moving incredibly fast. In space, everything is moving at tremendous speeds relative to everything else. You might be traveling at thousands of miles per hour, but you'd have no way to feel it. With no air resistance and no points of reference, you'd feel perfectly still, even as you hurtled through the cosmos at speeds that would seem impossible on Earth. After a year in space, you'd have become something like a cosmic mummy. Your body would be perfectly preserved, but also fundamentally changed by the extreme conditions of space. The radiation would have continued to work on your tissues, creating chemical changes that would make you look different from any human who had ever lived. Your body would have reached equilibrium with the temperature of space. In the deep void between stars, this is about 2.7 Kelvin, or about minus 455 degrees Fahrenheit. This is close to absolute zero, the coldest temperature possible in the universe. At this temperature, all molecular motion nearly stops. Your body would be colder than anything that has ever existed on Earth. But here's something amazing. Even at this temperature, your body would still be subject to the laws of physics. You'd still have mass, you'd still create a gravitational field, incredibly tiny, but still there. And you'd still interact with the electromagnetic forces of the universe. You'd be a part of the cosmic web, connected to everything else in the universe through the fundamental forces that govern reality. The first decade. The long journey. 10 years into your journey, you'd have traveled an incredible distance. Depending on your initial velocity and the gravitational forces acting on you, you might have traveled billions of miles from where you started. You might have passed by other planets, other stars, other solar systems. If you were lucky, you might have been captured by the gravitational field of a planet or moon. You'd become an artificial satellite, orbiting your new home for potentially millions of years. From space, you'd look like just another small asteroid or piece of space debris. If you were unlucky, you might have crashed into a planet or star. The impact would have vaporized your body instantly, turning you into a brief flash of light and heat. In a strange way, this would be the closest thing to a funeral you could have in space, a brief, brilliant goodbye to the universe. The first century, beyond human comprehension. 100 years into your journey, you'd have become something beyond human comprehension. You'd be a relic from a distant past, a frozen snapshot of early 21st century humanity floating through a universe that had continued to evolve and change around you. The solar system you came from would have changed. The planets would have continued their orbits, the sun would have aged, and humanity, if it still existed, would have advanced in ways you could never have imagined. You'd be a link to a past that might be completely forgotten. But you'd also be something more. You'd be a messenger from Earth, carrying the story of humanity into the far reaches of the universe. Even in death, even frozen and transformed, you'd be representing our species to the cosmos. If any alien civilization ever found you, you'd be their first contact with humanity. The first millennium, an archaeological treasure. 1,000 years into your journey, you'd have become an archaeological treasure of incredible value. You'd be the oldest human artifact in space, a perfectly preserved example of early space-age humanity. Your body would contain information about our species, our technology, our biology, and our history that would be invaluable to future archaeologists. Your DNA would still be intact, frozen in time. Scientists could potentially extract genetic information from your cells and learn about the human genome as it existed in the early 21st century. They could study your bone structure, your muscle tissue, your organs, and learn about how humans lived and died in this era. You'd also be a record of early space technology. Your spacesuit, if you were wearing one, would show what kind of materials and designs humanity was using when we first ventured into space. Your tools, your equipment, your personal belongings would all be snapshots of a bygone era. The first 1,000,000 years. A cosmic time capsule. 1,000,000 years into your journey, you'd have become something truly extraordinary. A cosmic time capsule. You'd be carrying the story of humanity from the early space age into the far future, long after our species might have evolved into something completely different or disappeared entirely. The universe around you would have changed in ways that are impossible to imagine. Stars would have been born and died, galaxies would have collided and merged. The very structure of space-time might have evolved in ways that challenge our current understanding of physics. But you'd still be there, floating through the cosmos, a frozen reminder of what humanity once was. You'd be a link between the ancient past and the distant future, a bridge across time that carries the essence of our species into the unknown. The deep future, beyond imagination. What happens next is beyond the scope of human imagination. You'd continue floating through space for billions of years, potentially outlasting the sun, the solar system, and even the galaxy itself. You'd witness the heat death of the universe, the final expansion of space-time, and the ultimate fate of all matter and energy. In the deepest possible future, trillions of years from now, even your atoms would begin to decay. Protons, once thought to be stable forever, would break down into simpler particles. Your body would slowly dissolve into the quantum foam of empty space, becoming one with the fundamental structure of reality itself. But even then, the information that made you who you were would never be truly lost. According to some theories in physics, information cannot be destroyed, only transformed. The pattern of atoms and energy that once made up your body would continue to exist in some form, scattered across the universe but never truly gone. The philosophical implications. This brings us to some profound philosophical questions. What does it mean to be human when you're floating alone in the infinite void? What is the value of a single human life when measured against the vast scale of the universe? Are we significant, or are we just cosmic dust? I think the answer depends on how you look at it. From one perspective, a human floating in space is utterly insignificant. You're smaller than a speck of dust compared to the vast scale of the universe. You're gone in an instant when measured against cosmic time. You're less than nothing in the grand scheme of things. But from another perspective, you're the most significant thing in the universe. You're a conscious being, capable of thought, feeling, and creativity. You're a pattern of matter and energy that has organized itself into something capable of understanding its own existence. You're the universe becoming aware of itself. The real science behind the horror. Now, let me take a moment to separate the science from the speculation. Everything I've described about what happens to your body in space is based on real scientific understanding. The boiling saliva, the swelling skin, the freezing process, the radiation effects, these are all real phenomena that would actually occur. NASA and other space agencies have studied these effects extensively. They've tested the effects of vacuum on biological tissues, studied how radiation affects the human body, and calculated the thermal dynamics of objects in space. The picture I've painted for you isn't science fiction, it's science fact. The only speculation comes when we talk about the far future, about what might happen over millions or billions of years. But even then, the basic physics is sound. We know how objects behave in space over long periods of time. We know how radiation affects matter. We know how gravity works over cosmic distances. Why this matters? You might be wondering why any of this matters. Why should we care about what happens to a human body floating in space? It's a morbid topic, and it's not exactly practical knowledge for most of us. But I think it matters for several reasons. First, it helps us understand just how hostile space really is. When we talk about space exploration, about sending humans to Mars or beyond, we need to understand what we're up against. Space isn't just empty, it's actively trying to kill us in ways that are both immediate and long-term. Second, it helps us appreciate just how precious and fragile life really is. The fact that we exist at all, that we can think and feel and love and dream, is a miracle when you consider the vast hostility of the universe around us. We're living in a tiny bubble of warmth and safety on a small planet, surrounded by infinite danger. Third, it helps us understand our place in the universe. We're not separate from the cosmos, we're part of it. Our atoms were forged in the hearts of dying stars. Our bodies are made of the same stuff as planets and moons and asteroids. When we die, we return to the universe that created us. The human story. But perhaps most importantly, the story of what happens when you float forever in space is really a story about what it means to be human. It's about our incredible fragility and our incredible resilience. It's about our ability to imagine ourselves in impossible situations and to find meaning even in the face of ultimate meaninglessness. The human floating in space represents all of us. We're all floating in space, really, on a small planet orbiting an ordinary star in an unremarkable galaxy. We're all alone in the vast cosmos, trying to make sense of our existence. We're all heading toward the same ultimate fate: death, dissolution, and a return to the cosmic dust from which we came. But while we're here, while we're alive and conscious and capable of thought, we're the most remarkable thing in the known universe. We're patterns of matter and energy that have organized themselves into something capable of love, creativity, and understanding. We're the universe's way of understanding itself. The message of hope. So while the story of floating forever in space might seem like a tale of cosmic horror, I think it's actually a message of hope. It reminds us that our time here is precious precisely because it's limited. It reminds us that consciousness is a rare and valuable thing in a universe that seems designed to destroy it. It reminds us that we're all in this together, floating through space on our small planet, trying to make sense of our existence. We're all fellow travelers in the cosmic journey, and we should take care of each other while we can. And it reminds us that even in the face of ultimate meaninglessness, we can create meaning. We can love each other. We can create art and music and literature. We can explore the universe and try to understand our place in it. We can make our brief time here matter. The beginning of the journey. So as we begin this journey together, exploring what happens when you float forever in space, remember that we're not just talking about death and destruction. We're talking about life and consciousness and the incredible miracle of existence itself. We're about to explore the most hostile environment in the universe, but we're also about to discover what it truly means to be human. We're going to face the ultimate questions about life, death, and our place in the cosmos. And we're going to do it together. So buckle up, because this is going to be one hell of a ride through the infinite darkness of space, and I promise you'll never look at the stars the same way again. The universe is vast, cold, and hostile. But it's also beautiful, mysterious, and full of wonders we're only beginning to understand. And somewhere in that vast expanse, there might be others like us, conscious beings trying to make sense of their existence, looking up at the stars and wondering if they're alone. We're not alone. We have each other. And that makes all the difference in the universe. Now, let's dive deeper into this incredible journey and discover what really happens when you float forever in space. Let's begin our descent into this beautiful, terrifying cosmic story. Imagine the moment again, that snap of the tether. It wouldn't be a loud crack like in the movies. In the vacuum, it would be a silent, jarring vibration that travels through your suit, up your arm, and into your very bones. It's a feeling, not a sound. The feeling of being suddenly untethered from everything you know, from the entire human race. Your first instinct would be to reach out, a futile grasp at the ship that is now receding, not because it's flying away, but because you are, pushed by the last tiny bit of momentum from whatever severed your connection. It grows smaller and smaller, a star of safety shrinking in a sea of indifferent ones. The sheer, overwhelming panic would be a physical thing, a crushing weight in your chest that has nothing to do with air pressure. Your heart would hammer against your ribs, a frantic drumbeat in the cathedral of silence. Every survival instinct, honed over millions of years of evolution to deal with predators on the savanna, would scream at once, completely useless against the passive, unyielding enemy that is simple distance. What do you think would be the most terrifying thought in that moment? The loneliness. The knowledge that no one can hear you scream? Or the slow, creeping realization that your death will take minutes, or even hours? Share your deepest fear in the comments below. Now, let's really explore that silence. It's more than just the absence of sound. It is a physical presence. On Earth, even in the most soundproofed rooms, you feel the subtle pressure of the air around you. You hear the whisper of your own circulatory system, a faint hum that you've been accustomed to since birth. But in space, all of that is gone. The silence is so profound that your brain might try to create its own sounds to fill the void, a phenomenon known as auditory pareidolia. You might start to hear faint music, whispers, or clicks that aren't really there. It's the sound of your own mind trying to make sense of an environment it was never designed for. The only real sounds would be the ones happening inside your own body, amplified to a terrifying degree. The glug-glug of your digestive system would sound like a monstrous plumbing system. The thump-thump of your heart wouldn't be a reassuring rhythm, but a frantic, desperate pounding. And your breathing? Oh, your breathing would be the loudest thing in the universe, a rasping, ragged sound that would be your only proof that you were still alive. Let's return to the horrifying transformation of your body, a process called ebulism. It's not an explosion, it's a grotesque inflation. Without the 14.7 pounds per square inch of atmospheric pressure we live under every second of our lives, the boiling point of the fluids in your body plummets. The water on the surface of your tongue, your eyes, and in your mouth would instantly begin to boil, not from heat, but from the lack of pressure. Imagine the feeling of your mouth filling with a cold, bubbling foam. The moisture lining your lungs would begin to vaporize as well, creating a sensation of drowning and burning simultaneously. And then there's the swelling. The nitrogen dissolved in your blood would come out of solution, forming tiny bubbles. These bubbles would act like millions of tiny seeds for more boiling, turning your blood into a fizzing, frothy mess. This isn't a quick process. It would be a slow, steady expansion. You would watch in horror as your fingers swelled into sausages, your arms and legs ballooning, your face becoming an unrecognizable, bloated mask. Your skin, incredibly, is strong enough to contain this. It would stretch taut, becoming smooth and shiny, like an overinflated balloon. You'd double in size, but you wouldn't pop. You'd just become a silent, swollen caricature of a human being, a grotesque parody of life. While this horrifying swelling is happening, your body is fighting a war on two fronts with temperature. Any part of you facing the direct, unfiltered glare of the sun would be cooked by intense radiation. There is no atmosphere here to block the harmful UV, X-ray, and gamma radiation. Your skin on that side would blister and char within seconds, as if you'd been held in front of a blast furnace. Meanwhile, the side of your body facing away from the sun, the side in shadow, is looking out at the 2.7 Kelvin temperature of deep space. Heat would be pouring off you in the form of infrared radiation, a process that is much slower than freezing in a freezer on Earth, but just as relentless. You would be burning and freezing at the same time. Imagine one side of your face blistering and cracking from the heat while the other side becomes numb, the skin turning waxy and pale as ice crystals form in the cells. It's a bizarre and torturous experience that your nervous system would struggle to even comprehend. Which do you think would be worse, the burning or the freezing? Let me know your thoughts. Now, we come to the final, critical moments of your conscious existence. You have about 15 seconds. Let that sink in. 15 seconds to comprehend your fate, to see the earth as a beautiful, distant marble you can never return to feel your body betraying you in the most horrifying ways imaginable. The urge to hold your breath is a powerful, primal instinct. We're taught from a young age that it's what you do when you can't breathe. But in the vacuum of space, it's the single most fatal mistake you could make. The air in your lungs, even a small amount, is at a much higher pressure than the vacuum outside. Holding it in would be like trying to contain an explosion in a paper bag. The air would expand violently, rupturing the delicate alveoli, the tiny air sacs in your lungs where gas exchange happens. This would force air bubbles directly into your bloodstream, causing a fatal embolism that would travel to your heart and brain, killing you almost instantly. It would be an agonizing, explosive end. The only chance of extending your consciousness for a few more precious seconds is to do the most counterintuitive thing possible. Exhale. Force every last molecule of air out of your lungs. As you do, you would feel the cold, boiling sensation in your mouth and throat intensify. The world would begin to dim. Your vision would tunnel, the starfield blurring into streaks of light. The panic would give way to a strange, detached sense of confusion. And then, darkness. You would fall unconscious, not from pain, not from the temperature, but from simple hypoxia, the lack of oxygen to the brain. Your body would continue its silent, terrifying dance with the laws of physics. But you, the consciousness that is you, would be gone. Your last thought would likely not be profound. It would be a simple, confused question. What's happening? Your unconscious body is now a passive object, subject only to momentum and the gentle, inexorable pull of gravity. But the processes inside are not finished. Your heart might continue to beat for a few moments, spasming erratically as it tries to pump the frothy, bubbling fluid that used to be your blood. The electrical activity in your brain would fizzle out, the complex symphony of thoughts, memories, and emotions fading into a final, silent chord. After about 90 seconds, all internal biological functions would cease. You are now, officially, dead. But your journey has only just begun. Your body is now a time capsule, a frozen monument adrift in the cosmos. The swelling from embolism would slowly subside as your body freezes solid. The freezing process is slow. It would take probably 12 to 24 hours for your entire body mass to freeze through to the core. The outer layers would freeze first, your skin becoming hard and brittle like frozen leather. The cold would creep inwards, solidifying your muscles, your organs, your brain. Your eyes, being mostly water, would freeze into milky, opaque orbs, forever staring out into the void. Once frozen, your body enters a state of near-perfect preservation. The vacuum of space is one of the best preservatives imaginable. There are no bacteria to cause decomposition, no insects, no scavengers. You are in a sterile, deep frozen environment. If another astronaut were to come across your body a week later, you would look almost the same as you did the moment you froze, albeit a swollen, discolored, and frost-covered version of yourself. You would become a cosmic mummy, a silent, frozen statue orbiting in the darkness. The radiation, however, doesn't stop. Your body is being constantly bombarded by a storm of invisible particles. Galactic cosmic rays, the nuclei of atoms accelerated to near the speed of light by distant supernovae, would pass through your body like microscopic bullets. They would shatter molecules, break DNA strands, and slowly, over centuries, alter the very chemical makeup of your frozen tissues. It's a slow, cosmic form of cooking. Your skin would gradually darken, turning a deep brown or black over the course of decades and centuries. It's like a photograph being slowly overexposed, the details fading into a dark, uniform shade. And what of your path? Where are you going? Your trajectory is a beautiful, complex dance of celestial mechanics. If you were on a spacewalk around Earth, you'd likely be in a low Earth orbit. But low is a relative term. You would be screaming across the sky at nearly 17,500 miles per hour. From the ground, if anyone could see you, you'd be a fleeting streak of light, a man-made shooting star. But this orbit wouldn't be stable forever. The faint wisps of the Earth's outermost atmosphere, even at that altitude, would create a tiny amount of drag. Over months, or perhaps years, this infinitesimally small friction would slow you down, causing your orbit to decay. You would spiral gently, slowly, inwards. Each orbit would be slightly lower than the last. You would pass through the orbits of satellites, a ghostly and macabre companion to the technology of the world you left behind. Eventually, you would reach the denser layers of the atmosphere, and this is where your cosmic journey would meet a fiery, spectacular end. Hitting the atmosphere at such a high velocity would be like running into a brick wall. The friction would be immense, and your frozen body would heat up rapidly. It would incandesce, glowing red, then orange, then white-hot. You would become a brilliant meteor, a fireball streaking across the sky for anyone on the night side of the Earth to see. Most, if not all, of your body would be vaporized, turned back into the fundamental atoms from which it was made. A final, beautiful flash of light, a momentary tribute to a life that ended in the loneliest place imaginable. A person might see it from their backyard, make a wish, and never know they just witnessed the funeral pyre of an astronaut. But what if you weren't in low Earth orbit? What if the accident that sent you adrift pushed you away from Earth, out into the wider solar system? This is where the story gets even grander. Your trajectory could be anything. A gentle nudge could send you on a path that intersects with the moon. After a journey of a few days, your frozen body could impact the lunar surface. There is no atmosphere on the moon to burn you up. You would strike the ground at thousands of miles per hour, creating a new, small crater in the ancient pockmarked dust. You would be instantly vaporized upon impact, your atoms mingling with the lunar regolith. For the rest of time, a tiny fraction of that crater would be composed of the remains of a human being. Your final resting place would be on another world, under a black sky where the Earth hangs like a giant blue and white marble. Or perhaps your trajectory sends you sunward. You would fall towards our star, accelerating faster and faster as you get closer. The intensity of the sun's radiation would increase exponentially. Your frozen body would begin to thaw, then boil, then sublimate, turning directly from a solid into a gas. You would be stripped away, layer by layer, by the solar wind. Before you ever reach the sun's surface, you would have completely evaporated, becoming a diffuse cloud of atoms caught in the sun's immense gravitational field, eventually becoming part of the sun itself. You would be returned to the star that gave life to your planet. The possibilities are almost endless. You could be flung outwards, towards the gas giants. Imagine your silent, frozen form drifting past Mars, a tiny speck against the red desert. Then, years later, you sweep into the majestic system of Jupiter. You would be a grain of sand next to this colossal world. You might get captured by its immense gravity, becoming a new tiny moon of Jupiter, joining the 95 others in their eternal dance. You would orbit for eons, witnessing the swirling storms of the Great Red Spot, the volcanic plumes of Io, the icy shell of Europa. You would be a silent observer of wonders no human has ever seen up close. What a spectacular, albeit lonely, fate. If you were found by a future mission to Europa, what would they think? What story would your frozen body tell them about the dawn of space exploration? This is a future I find both haunting and beautiful. And so, your body continues its journey, a silent testament to a brief moment of tragedy. You are no longer a person, but a piece of celestial debris, a curiosity for physics, a cosmic message in a bottle. Your flesh has become harder than granite from the cold. The constant, low-level radiation has subtly rearranged your molecular structure, but you are still, fundamentally, you, your unique combination of elements. The very atoms that once held your thoughts and dreams are still bound together. For now, the universe, however, has an infinitely long time to work on you. The journey through the first few years, decades, and centuries is just the beginning. The real transformation, the one that erases the final traces of your humanity and blends you back into the cosmic whole, takes place on timescales that are difficult for the human mind to even hold. We are talking about millions and even billions of years. Your simple, frozen form is about to embark on a journey through deep time, a journey that will see the stars themselves change and the galaxy evolve. You are a silent passenger on Spaceship Infinity, and the next leg of your journey will take you far beyond the familiar shores of our solar system. We'll follow the path of the traveler who was flung outwards, away from the sun, on a voyage into the unknown. After escaping the gravitational pull of the planets, your frozen form would spend thousands of years crossing the Kuiper Belt, the realm of dwarf planets like Pluto and countless icy bodies. Then, you would enter a space of profound emptiness that lasts for millennia. But this emptiness is just the prelude to the true border of our solar system, the Oort cloud. It's not a cloud of water vapor, but a colossal spherical shell of trillions of icy comets loosely bound to our sun, marking the very edge of its gravitational kingdom. It's a place of deep, deep cold and almost perfect silence, a cosmic graveyard of primordial material left over from the formation of the planets. Your journey through it would take tens of thousands of years. Imagine your frozen body, a tiny, dark speck drifting silently through this immense, dark sphere. You would pass by dormant comets, some as big as mountains, others as small as pebbles. They are ghosts, waiting for a gravitational nudge from a passing star to send them on a million-year journey towards the sun, where they will blaze to life. In this place, the sun is no longer a dominant, life-giving disk. It is just the brightest star in the sky, its warmth completely gone, its light a pale, distant pinpoint. You are now truly leaving home. Finally, after a journey of perhaps 30 years, you cross the outer edge of the Oort cloud. You are now in interstellar space. The umbilical cord to our sun is finally severed. You are an orphan of your star, a true wanderer of the Milky Way galaxy. The feeling, if you could feel, would be one of absolute liberation and absolute loneliness. The very concept of direction becomes abstract. Up and down have no meaning. Your trajectory is now governed by the fantastically complex gravitational web of the entire galaxy. You are caught in a slow cosmic river, flowing between the stars. The space between stars is not a perfect vacuum. It's filled with the interstellar medium, a tenuous mixture of gas, mostly hydrogen and helium, dust, plasma, and radiation. As you travel through this medium for millions of years, it has a subtle but profound effect on your body. It's like the gentlest form of sandblasting imaginable. Individual atoms of hydrogen and microscopic dust grains, relics of exploded stars, would impact your frozen form. Each impact is insignificant, but over millions of years, they add up. It is the universe's slowest act of erosion. The radiation darkened, brittle outer layers of your skin would be slowly scoured away, molecule by molecule. It's a process of purification, stripping away the outer damage and revealing the deeper, more preserved layers beneath. It's as if the galaxy itself is trying to polish you, to smooth your rough edges, preparing you for a future unknown. As the millennia slide into millions of years, the view from your frozen eyes would change dramatically. The familiar constellations we see from Earth would warp and dissolve. This is because the stars are not fixed points on a celestial sphere. They are all moving, each with its own velocity and direction, orbiting the center of the Milky Way. From your wandering perspective, the sky would be a slow, majestic, ever-changing dance. The 3 stars of Orion's belt would drift apart, their straight line broken forever. The Big Dipper would unbend, its handle and cup scattering into a meaningless jumble of stars. Polaris, our North Star, would wander away from its post. You would witness the birth and death of constellations, a celestial ballet played out over eons. It's a perspective that no human has ever had, a direct view of the dynamic, living nature of our galaxy. The sky would become an unfamiliar wilderness of stars. The only constant would be the faint, glowing band of the Milky Way itself, the collective light of billions of stars in the galactic plane, a shimmering river of light that would be your constant companion on this endless journey. If you could have one constellation preserved forever, which one would it be and why? What pattern in the stars brings you a sense of comfort or wonder? Let me know in the comments. Your journey is unlikely to be entirely uneventful. The galaxy is a busy place. Over millions of years, your path might take you through a stellar nursery, a vast nebula of brilliantly colored gas and dust where new stars are igniting. Imagine drifting into a cloud of glowing pink hydrogen and deep blue oxygen, a cosmic womb hundreds of light years across. It would be a place of breathtaking beauty, a celestial cathedral of light and color, but it would also be a place of intense danger. The young, hot, massive stars within these nebulae unleash ferocious amounts of ultraviolet radiation. This radiation would be far more intense than what you experienced from our own sun. It would accelerate the degradation of the complex molecules in your body, breaking down the remaining proteins and cellular structures. It's a bath of creative and destructive energy. You would be simultaneously witnessing the birth of new suns while your own form is being slowly unmade by their violent light. It's a beautiful, cosmic paradox. Or perhaps your path takes you near the scene of a cosmic death. You might drift through the expanding shell of a supernova remnant. Millions of years ago, a massive star in this region reached the end of its life and exploded in an event that would have briefly outshone the entire galaxy. What's left is a tangled, expanding web of superheated gas and heavy elements that were forged in the heart of the dying star. Drifting through this remnant, your body would be bombarded with atoms of gold, platinum, uranium, elements essential for life as we know it, now scattered through space. You would be seasoned with stardust from a cataclysmic event. The shockwave from the ancient explosion, still traveling outwards, might even be strong enough to slightly alter your trajectory, sending you off in a new direction on a new, unknown path. You become a part of the cycle of stellar death and rebirth, a silent carrier of the elements that will one day form new planets and perhaps new life. Your body, once a vessel for a single life, is now a tiny piece of the galactic ecosystem, a carrier of its history and its potential. Let's now entertain a truly mind-bending possibility. After millions upon millions of years of drifting through the interstellar void, your journey might, against all odds, take you towards another star system. The chances are astronomically small, but the universe is a very large place with a very long time for things to happen. As you approach this new star, its gravitational pull would begin to dominate your trajectory. You would begin to fall towards it, accelerating once more after eons of coasting. You would sweep through this alien solar system, a visitor from a distant star named Sol. What would you see? Planets of colors and sizes unknown to us? Moons locked in strange and beautiful orbits? A ringed gas giant that dwarfs our Saturn? You would be the first emissary of Earth to ever visit another star, a silent, frozen ambassador. Now, let's take this one step further. What if this solar system is not just home to planets, but to life? And not just microbial life, but an intelligent, spacefaring civilization. Imagine a ship from this civilization on a routine patrol of their outer system. Their long-range sensors detect an anomaly. It's a tiny object, only a couple of meters long, moving on a hyperbolic trajectory, meaning it's coming from interstellar space. Its velocity and path are unusual, but what's truly baffling is its composition. It's not a rock. It's not an icy comet. It's rich in complex carbon compounds and has a strange thermal and radio signature. Intrigued, and perhaps a little alarmed, they decide to investigate. Their ship silently approaches your frozen, brittle form. On their screens, they see a sight that would change their civilization's history and philosophy forever. It's a bizarre, symmetrical object, darkened and pitted by eons of radiation and micrometeoroid erosion. It has 4 limbs and a head-like appendage. It is unmistakably the remains of a once-living being. They have just found conclusive proof that they are not alone in the universe. Your lonely journey has ended in the most profound discovery in their history. The alien scientists would be ecstatic and cautious. They would bring your body aboard their vessel in a sterile, zero-G containment field. Their instruments, likely far beyond our own, would begin to analyze you. They would see the brittle bones, the remnants of mineralized tissues. They would note the strange, stretched quality of the skin, a clue to the vacuum exposure you suffered. They would map the microcraters from dust impacts, using them to calculate how long you had been traveling and from which direction you came. You would be a puzzle box of cosmic proportions. But the real treasure, the thing that would send shockwaves through their scientific community, would be found deep inside your cells, protected from the worst of the radiation by the layers of frozen tissue. They would find fragments of your DNA. For an advanced biological science, this would be like us finding the Library of Alexandria perfectly preserved. It's a complete genetic blueprint for an alien life form. They could sequence it. They could learn about our 4-base pair genetic code, so different, perhaps, from their own. They could deduce our evolutionary history, our relationship to other life on our home planet. They could see the genetic markers for our strengths and our weaknesses, our potential for intelligence and our susceptibility to disease. They would learn what we look like, how our bodies functioned, what kind of environment we evolved in. Your body would tell them everything. You would be humanity's first, and perhaps only, ambassador to the stars. The philosophical and cultural impact on their society would be immense. All their myths about creation, their place in the universe, would be challenged. They would know that, out there, in the direction of a small yellow star a few thousand light years away, a species of intelligent, tool-using bipeds existed. Because the time it took you to travel there would mean that the civilization that sent you is long gone, or has evolved into something unrecognizable. You would be a ghost, a message from the past. They might wonder what happened to us. Did we destroy ourselves? Did we succumb to a natural disaster? Or did we transcend our physical forms and move on in a way they can't comprehend? Your single, silent body would spark 1,000 new religions, 1,000,000 new philosophical debates. It would likely galvanize them to explore the stars with a newfound purpose, to search for the home of the strange, frozen traveler they found in the dark. Your accidental death would have become the single most important event in the history of another world. What a legacy that would be! It elevates a simple, tragic death into something of cosmic, almost mythical, significance. Your story would be told for generations on a world you never knew existed, a world that only knows of humanity because of your lonely, silent voyage across the great empty sea between the stars. But let's pull back from that incredible possibility for a moment and consider a more likely, yet no less profound, long-term fate. Let's say your body is never found. It continues its journey through the Milky Way for not just millions, but billions of years. On this timescale, the galaxy itself evolves. You would witness, in ultra-slow motion, our Milky Way galaxy on its inevitable collision course with our neighbor, the Andromeda Galaxy. This cosmic merger, which is set to begin in about 4.5 billion years, will be a spectacular event. From your perspective, you would see the sky begin to fill with a new set of stars, the stars of Andromeda. Over hundreds of millions of years, the two galaxies would pass through each other like ghosts. Gravity would fling stars and gas clouds into new orbits, creating tidal tails and triggering a massive burst of star formation. The night sky would be chaotic and brilliant, filled with new nebulae and bright young stars. You would be caught in this gravitational dance, your trajectory completely randomized, perhaps flung into a high orbit around the new, larger galaxy, which some astronomers have dubbed Milkomeda. You, a tiny relic from a small planet called Earth, would be a witness to the birth of a new galactic empire. You would outlast your home planet, which by this time would have been consumed by our sun's transformation into a red giant. You would outlast the sun itself. You are now an artifact not just of a species, but of an entire solar system that no longer exists. Let us now push forward into the truly deep future, a future so distant that the mind struggles to grasp the scale of it. Your frozen body, having witnessed the birth of the Milkomeda Galaxy, continues its silent drift. But the universe around you is growing old. The furious burst of star formation triggered by the galactic merger has long since subsided. The great nebulae have been used up, their gas locked away into stars. The universe is running out of fuel. The era of bright, young blue stars is a distant memory. The cosmos is now entering its twilight years, the stelliferous era giving way to the degenerate era. The only stars still shining are the red dwarfs. These are the universe's survivors, the frugal, slow-burning embers of creation. They sip their hydrogen fuel so slowly that they can live for trillions of years. The universe is now a vast, dim, red-lit place. The sky from your perspective is no longer a brilliant tapestry of white and blue diamonds, but a sparse scattering of faint, ruby-red points of light. It's a perpetual, galaxy-wide sunset that will last for 1 trillion years. The cold deepens. The silence becomes even more profound. You are a wanderer in a dying, cooling universe. During this immense, red-lit era, your journey continues to be shaped by gravity. The galaxy, though old and dim, is still a dynamic place. Stars, or what's left of them, continue their orbits. Your path could bring you close to one of the stellar corpses that now populate the cosmos. Imagine drifting near a white dwarf. This is the dead core of a star like our Sun. It's a sphere of supercompressed carbon and oxygen, about the size of the Earth, but with half the mass of the Sun. It no longer generates heat through fusion, but it is still fantastically hot from its formation, glowing with a brilliant white light that would illuminate your frozen form in the darkness. The gravity would be intense. If you pass too closely, tidal forces could rip your brittle, frozen body apart, scattering your remains into a stream of icy dust that would eventually form a faint ring around the dead star. You would become a decoration for a stellar tombstone. Or perhaps your path takes you near a neutron star. This is something else entirely. The remnant of a massive supernova. It is a city-sized sphere so dense that a single teaspoon of its material would weigh billions of tons. Its gravity is monstrous, second only to a black hole. Its magnetic field is trillions of times stronger than Earth's. As your body, composed of charged particles, drifted through this magnetic field, it would induce powerful electrical currents, potentially shattering your molecular bonds. You would be unmade by the ghost of a star's dead heart. But the most profound encounter would be with a black hole. These are the true rulers of the degenerate universe. As you drift closer to a stellar mass black hole, you would witness the laws of physics being pushed to their absolute limits. The first thing you'd notice is the gravitational lensing. The faint, distant red dwarf stars behind the black hole would appear to warp and bend. Their light would be twisted into strange arcs and multiple images, forming an eerie visual effect called an Einstein ring if the alignment was perfect. The black hole itself is invisible, a perfect sphere of blackness against the blackness of space. Its presence is only betrayed by the way it distorts the reality around it. If your trajectory was just right, you wouldn't fall straight in. You would be captured into orbit, becoming a tiny, frozen moon for this monster. You would be on the innermost stable orbit, screaming around the event horizon at a significant fraction of the speed of light. Time for you would slow down dramatically relative to the rest of the universe. While millennia passed in the outside cosmos, you would experience only hours. You would be a time traveler, watching the universe age in fast forward. Eventually, your orbit would decay due to the emission of gravitational waves, and you would begin your final, slow spiral inwards. You would cross the event horizon, the point of no return. What happens inside is unknown, but your physical form would be crushed out of existence, your mass and energy added to the black hole. You would become one with the singularity. After trillions upon trillions of years, the last red dwarf star finally flickers and dies, cooling over eons to become a black dwarf. The universe is now truly dark. The degenerate era has fully begun. There are no more stars. The only light comes from the very rare and fantastically violent collisions of these stellar remnants, like two white dwarfs spiraling into each other to create a brief, final supernova. These flashes would be the last fireworks in a cold, dark, empty hall. The universe is now populated only by these dead stars, black dwarfs, neutron stars, and black holes, and planets, asteroids, and the frozen bodies of any life that once existed, all drifting silently through the eternal night. Gravity is now the only force doing any meaningful work on a large scale. Over timescales that make the age of the universe so far seem like a fleeting instant, the galaxy itself will begin to dissolve. Through a process called gravitational relaxation, the orbits of the dead stars will slowly change. Some will be flung out of the galaxy entirely, ejected into the almost perfect emptiness of intergalactic space. Your body could be one of them, cast out of the ghostly structure of Milkomeda to wander alone in the great void. Others will do the opposite. Their orbits will decay, and over countless eons, they will fall towards the supermassive black hole at the center of the galaxy, feeding it and making it grow. The galaxy, once a brilliant spiral of light and life, will slowly evaporate, leaving behind a few scattered stellar corpses and a single gargantuan black hole. And now we arrive at the most mind-bending part of your journey, the final dissolution. In this dark, empty future, even the things we consider eternal are not. Matter itself is not stable on these timescales. According to some of the most advanced theories of physics, protons, the fundamental building blocks of the atoms that make up your body, are not truly stable. They are predicted to decay, but their half-life is enormous, something on the order of 10 to the power of 34 years or more. This number is so large that it is meaningless in human terms. But the universe has that much time to wait. And so, after trillions of trillions of trillions of years of floating as a perfectly preserved frozen statue, your body would begin to disappear. It would not be a violent process. It would be the quietest, most gentle, most final end imaginable. Deep inside a carbon atom in what was once a bone cell, a single proton suddenly decays. It vanishes, transforming into a positron and a neutral pion, which itself immediately decays into a pair of high-energy gamma-ray photons. A tiny, imperceptible puff of light and energy is released. All that is left is a slightly lighter, different atom. 1,000,000 years might pass before it happens again, in another atom. It's the ultimate form of evaporation. Slowly, atom by atom, your body, which has survived the vacuum, the cold, the radiation, the birth of a galaxy, and the death of all stars, would begin to dissolve. It would be like a statue made of sugar being rained on by a single drop every 1,000,000,000 years. The complex structures of your cells, your DNA, the very minerals in your bones would be unmade from the inside out. The process is fantastically slow. It would take an unimaginable amount of time for your entire body to decay away. But eventually, the last proton would decay, the last atom would vanish. Your physical form, the one that carried you on this incredible journey across space and time, would be gone. You would have evaporated into a diffuse, expanding cloud of faint radiation, photons, neutrinos, and positrons, the fundamental ghosts of matter. You would have returned to pure energy, spread so thinly across the vastness of space as to be undetectable. The universe has finally, completely reclaimed you. You are gone. But are you? Is everything that was you truly erased? What do you think happens to your consciousness, your essence, when not a single atom of your body remains? Does it simply cease to be, or does it transform into something else? This is a question that teeters on the edge of physics and philosophy, and I'd love to hear your thoughts down below. This leads us to the final, beautiful, and deeply strange concept: the legacy of information. According to a key principle in physics, information can never be truly destroyed. The total amount of information in the universe is constant. So, what happened to the information that constituted you? This includes your unique genetic code, the precise structure of your brain's neural network which held your memories, your personality, your thoughts, and your dreams. The physical substrate is gone, but the pattern, the information, might persist. How? The exact mechanism is a topic of intense debate among physicists. Perhaps the information is preserved in the subtle correlations of the particles you decayed into, a faint and complex pattern in the radiation that spreads out from where your body once was. Or, in the scenario where you fell into a black hole, some theories, like the holographic principle, suggests that the information that was you isn't destroyed at the singularity but is somehow smeared out and stored on the two-dimensional surface of the event horizon, like data saved on a cosmic hard drive. In the even more distant future, even the black holes themselves will evaporate. Through a process called Hawking radiation, they will slowly leak energy back into the universe over truly staggering timescales. A supermassive black hole could take 10 to the power of 100 years to evaporate completely. And as it does, it's theorized that the information it once consumed is slowly released back into the universe in a scrambled, chaotic form. So, the information that was you, either stored on the horizon or released during evaporation, would once again be free, imprinted on the low-energy photons and particles that are all that's left in the universe. You would no longer exist as matter, but as pure information, a ghost in the machine of the cosmos, a complex whisper in the background noise of a dead universe. Your legacy is the story of your existence, written in the fundamental language of physics, a story that can never be erased. From a dramatic, terrifying death in the vacuum of space to a frozen cosmic mummy, a witness to galactic birth and stellar death, and finally, to a pattern of information woven into the fabric of space-time itself. Your journey is, in the end, the journey of the universe itself. From organized complexity to ultimate dissolution and the eternal persistence of the story that once was. You become a part of the universe's memory. And in a cosmos with no one left to remember, that might be the only kind of immortality that truly matters. Let's pull back from that abyss of deep time, from the edge of the universe's final breath. The story of that single, frozen body took us to the end of everything, to a future so remote it feels more like a dream than a possibility. But its journey began in a single human moment of terror and awe. We followed the physics of its dissolution, but what about the soul of the story? Let's rewind the clock, back to the beginning, back to that moment of separation. But let's change the rules of this cosmic game just a little. Let's imagine you are not naked in the void. Let's imagine your suit holds. Its propulsion system is dead. Your radio is silent, a victim of whatever accident cast you adrift, but your life support is miraculously intact. You have oxygen for 24 hours. Your suit will protect you from the vacuum, regulate your temperature, shield you from the worst of the immediate radiation. You are alive, but you are also stranded. You are a castaway on the most desolate island in existence, a personal, form-fitting prison of survival, drifting in the infinite ocean of space. You will not die in 90 seconds. You have been given the cruel gift of time. Time to think, time to watch, and time to understand the true meaning of being alone. The first hour is a frantic blur of adrenaline and procedure. You are an astronaut trained for crisis. You don't panic, not yet. You run diagnostics. You check every system. You try the radio again and again, cycling through every channel, listening to the static, a hiss that is the sound of your hope dying. You check your trajectory, your suit's computer confirming what your eyes can already see. Your path is not taking you back towards the station, but away from it. The station is no longer a haven, but a shrinking star of light, one among millions. The math is cold, simple, and absolute. There is no rescue coming. No one can reach you in time. The numbers on your oxygen display are no longer a simple readout. They are a countdown clock to your own extinction. The initial shock gives way to a cold, creeping dread that settles deep in your bones. You have 23 hours left to live. What do? You are a ghost, already dead, but still walking. A phantom in a spacesuit, your only companion the steady, gentle hum of the life support system that is both your savior and your executioner's metronome. So you decide to watch. What else is there to do? You orient yourself so that you are facing the Earth, your home, and you are treated to the most spectacular, most heartbreaking show in the universe. You watch your planet, not as a scientist, not as an explorer, but as a condemned soul watching paradise from across an impassable chasm. You see the whole of it. You watch the sun rise over the curve of the Earth, a brilliant, blinding flash of pure white light that paints the atmosphere in strokes of impossible blue and violet. You see the Terminator, the line between night and day, sweeping silently across the continents, a slow, majestic wave of light. You see weather systems, vast, swirling hurricanes of white cloud that look as gentle as cotton wool from up here, belying the fury they hold within. You drift over the deep sapphire blue of the Pacific, a seemingly endless expanse of water. You see the familiar shapes of the continents, the brown and green patchwork of the land. You can see the great mountain ranges, the Himalayas and the Andes, like jagged, snow-capped wrinkles on the planet's skin. You look for signs of life, of humanity, and as the Earth continues its slow, steady rotation, you see them. As you pass into the planet's shadow, the night side comes alive. You see the sprawling, glittering webs of cities, constellations of golden light on a dark canvas. Paris, Tokyo, New York. They look like clusters of fallen stars, beautiful and delicate. You can see the straight, bright lines of highways connecting them. Each tiny point of light is a street lamp, a car, a window in a house where people are living their lives, completely unaware of the lone, silent observer watching them from the heavens. You see the light of your own hometown. You can pinpoint the exact spot where your family is sleeping, where your friends are laughing, where your life was supposed to be. It is the most beautiful thing you have ever seen, and it is a vision of pure, absolute torture. If you had only a few hours left in this situation, what would you choose to look at? Would you face the beautiful, painful sight of Earth, or would you turn your back on it and face the infinite, mysterious expanse of deep space? Let me know your choice in the comments. As the hours tick by, your mind, trapped in this box of isolation, begins to change. The constant, low hum of the suit's fans and pumps, once a reassuring sound, becomes a maddening presence. The absolute silence outside your helmet is a heavy blanket. Your world has been reduced to the size of your own body, to the rhythm of your own breathing, to the sight of the unblinking stars and the silent, turning world below. Sensory deprivation begins to set in. Your brain, starved of new stimuli, starts to create its own. You might see fleeting shadows in your peripheral vision, streaks of light that aren't meteors. You might start to hear things. A faint voice in the static of the dead radio. A piece of music from your childhood. The laugh of a loved one. You know it's not real. You are trained to understand these psychological effects. But knowing it doesn't make it any less real in the moment. The loneliness is a physical presence now. It's a coldness that your suit's heaters cannot touch. It's a weight that presses in on you from all sides. You are the most alone being in the history of the universe. Adam in the Garden of Eden was less alone than you are now. You are not just separated from humanity by distance, but by fate. You exist in a state of limbo, a tiny bubble of life in an ocean of death. Your existence has become a paradox. You think about your legacy. What will they say about you? You'll be a hero, of course. A tragic figure in the story of space exploration. They will name a crater after you, or a new spacecraft. School children will learn your name. But what does any of that matter to you, here, now? All you want is to feel the wind on your face one more time, to smell the rain, to hug your child. The grand legacy of history feels like a hollow, meaningless substitute for the simple, tactile reality of a life you can no longer have. You might try to leave a message. Perhaps you use a tool to scratch a few words onto a piece of your suit. A name, a short phrase, I love you. A final, desperate attempt to communicate, to leave a mark, a sign that you were here, that you were thinking of them at the end. It's a message in a bottle thrown into the cosmic ocean, a message that will likely never be read, but the act of writing it is a final act of defiance, a final affirmation of your humanity in the face of the vast, inhuman void. Thank you for joining me on this journey through the infinite. Before we part ways, I have one last question for you. After exploring all these possibilities, from the terrifying to the profound, has your view of humanity's future in space changed? Do you see it as an essential destiny we must pursue at all costs, or as a beautiful but perhaps foolish dream? Let's have one final, grand discussion in the comments. Your thoughts and perspectives are what make these explorations truly meaningful. Thank you for watching.